There are several applications of union find operation in algorithms. In this video, we will look at how union find operation can be used to check whether the vertices belongs to the same connected component. Let us consider a graph G. This graph has 7 vertices. Initially, we have an empty set. Now, since we have 7 vertices, so we will create 7 disjoint sets, each containing one vertex. We will also have a parent array P where all the elements are initialized to -1. Then we will perform union operation on sets if there is an edge between the vertices and the vertices are not in the same set. So we have an edge between vertex 1 and vertex 2. Now we need to find whether vertex 1 and vertex 2 are in different sets. Vertex 1 belongs to set 1 and vertex 2 belongs to set 2. So they are in different sets. Therefore, we will perform union of set 1 and set 2. So now after the union operation, both the vertices 1 and 2 will be in the same set. Then we have an edge between vertex 1 and vertex 4. Vertex 1 belongs to set which contains 1 and 2, and vertex 4 belongs to set 4. So they are in different sets. Therefore, we will perform union of set which contains 1 and 2 and set 4. So now after the union operation, vertices 1, 2 and 4 will be in the same set. Then we have an edge between vertex 2 and vertex 3. Now we need to find whether vertex 2 and vertex 3 are in different sets. Vertex 2 belongs to set which contains 1, 2 and 4. And vertex 3 belongs to set 3. So they are in different sets. Therefore, we will perform union of set which contains 1, 2 and 4 and set 3. So now after the union operation, vertices 1, 2, 4 and 3 will be in the same set. Then we have an edge between vertex 2 and vertex 4. Vertex 2 and vertex 4 belongs to the same set. Therefore, we do not perform the union operation. Then we have an edge between vertex 3 and vertex 4. Now we need to find whether vertex 3 and vertex 4 are in different sets. Vertex 3 and vertex 4 belongs to the same set. Therefore, we do not perform the union operation. Then we have an edge between vertex 5 and vertex 6. Vertex 5 belongs to set 5 and vertex 6 belongs to set 6. So they are in different sets. Therefore, we will perform union of set 5 and set 6. So now after the union operation, vertex 5 and 6 will be in the same set. Then we have an edge between vertex 5 and vertex 7. Vertex 5 belongs to set which contains 5 and 6, and vertex 7 belongs to the set 7. So they are in different sets. Therefore, we will perform union of set which contains 5 and 6 and set 7. So now, after the union operation, vertices 5, 6 and 7 will be in the same set. Then we have an edge between vertex 6 and vertex 7. Now, we need to find whether vertex 6 and vertex 7 are in different sets. Vertex 6 and vertex 7 belongs to the same set. Therefore, we do not perform the union operation. Now, we have examined all the edges of the graph and placed vertices in disjoint sets based on the edges between them. Now we can use union find operation to check whether the vertices belongs to the same connected component. The vertices u and v are in the same connected component if and only if there is a path between them. So let us find whether vertex 3 and vertex 4 belongs to the same connected component. To do this, we will perform the find operation passing vertex 3. The vertex 3 belongs to the set whose parent is 2, and 2 is the root of the set. So the find operation returns 2 for vertex 3. Then we will perform the find operation passing vertex 4. The vertex 4 belongs to the set whose parent is also 2, and 2 is the root of that set. So the find operation will return 2 for the vertex 4. Now since the parent of both vertex 3 and vertex 4 is same, as well as the find operation returns 2 for both the vertices 3 and 4, therefore Both the vertices 3 and 4 belongs to the same connected component. Let us find whether vertex 4 and vertex 6 belongs to the same connected component. To do this, we will perform the find operation passing vertex 4. The vertex 4 belongs to the set whose parent is 2 and returns 2 as the root of that set. Then we will perform the find operation passing vertex 6. The vertex 6 belongs to the set whose root is 5. Now since the root of vertex 4 is 2 and the root of vertex 6 is 5, therefore vertex 4 and vertex 6 belongs to different connected components. So this is how we can use the union find operation to find whether the vertices belong to the same connected component. Now let us look at the algorithm. We will call this algorithm as sameComponents. And this algorithm takes vertex u and vertex v as the parameters. Then within the algorithm, we have the if statement and a call to find function passing vertex u equal to and call to find function passing vertex v. If the find operation or the function returns the same root, then v will return true. That means vertex u and vertex v are in the same set and belongs to the same connected component. Otherwise, v will return false. That means vertex u and vertex v are not in the same set and belongs to different connected components. So this is the algorithm that uses the find operation to find whether vertices belongs to the same connected component. Now let us look at the time complexity of this algorithm. This algorithm contains if statement, which is a primitive statement, and takes constant time. But the if statement makes calls to find operation or the algorithm. And the find algorithm takes O of n as the time complexity. Therefore, the overall time complexity of this algorithm is O of n. So this is how we can use union find operation to find whether the vertices belongs to the same connected component.